Today we're going to do 3.5 scatter plots and lines of fit. Well, the first thing I would like for you to do is try out number 1, A, B, and C, and then I will go over the answers. All right, so for part A, we really just wanted you to see something like it's increasing, right? Maybe you explained something like in part B as well in part A, where you feel like the bigger the screen, the more it costs, okay? Obviously, towards the end, it seems to kind of drop down, so it's definitely not a perfectly linear thing, but it's definitely a positive increasing slope. For part C, I put my dot where I have the arrow. You could have had it in a different spot, but it would have been somewhat close to there. Somewhere between $300 or $400 and $500. Probably more specific would be between, the 400 from this spot and the like 480. So maybe saying between 4 and 480 would be more precise, but somewhere in there. Now let's talk about really what this all is. This is talking about correlations. So correlations, associations, slope, that's all pretty much the same thing. So as y increases, then x values also increase. Now notice how we use the word tend, because it could kind of drop off here and there. It doesn't have to be a perfect line, but it needs to be kind of like one. Okay, so it would be positive if it looks like it's following a pattern going up, right? It would be negative if it looks like it's going down, okay, kind of like that. And then no correlation would be if it's just a bunch of dots all over the place, right? There's nothing that's really happening there, and whatnot. Okay, so positive, negative, and no correlation. So notice how there's not a 0 or an undefined. It's just either positive or negative, or there is none. So for example, hopefully we can see these right away. We need positive, negative, and no correlation. And it actually goes in that exact value or exact order. So this one kind of looks like it's increasing this way, which would be a positive slope. Okay, we do want to use the word correlation. It's a positive correlation. Same thing here. We got a negative one because it looks like it's going down. And the last one would have no correlation, because there's not a line that I could really draw. I mean, maybe coming through there, that kind of gets you in the middle of it, but that's not a pattern at all. So that is no correlation. All right, so then we get into ones like this, where it says, how can the relationship of x and y be modeled? If the relationship models a linear function, describe the correlation between the two data sets. Okay, so notice how it says describe it. You're not really trying to come up with an equation, because this is not a linear thing, okay? Meaning like this isn't a perfect linear function. So we just want to see if maybe it kind of follows one, right? So if we focus on our x's, between each x value, it's going up by 1, right? So that is a perfect linear thing. The problem is when you start looking at the other side, your y's, we go up 1, then we go up 2, then we go up 0, then we go up 1. So notice how these middle two are kind of off, right? But still, if you follow this, this pretty much is linear. Okay, it goes up 2, but then it goes up 0, so it kind of evens itself out. So yes, this is linear, okay? So it models a linear function, right? It's close to 1. And what would it look like? Well, if you think about it, we are adding things, right? It is adding on one side, adding on the other, which means this would be a positive correlation. Okay, and you can see that by like plotting these, 2, 4, 3, 5, 4, 7, 5, 7, and then 6, 8, right? So it looks something like that, which clearly is increasing. So I've kind of already done this a little bit for number 3. It says, how can the relationship between hours after sunrise, so notice how that's down here, right? And the temperature, which is y, be modeled? Okay. Does this seem to be linear? Well, obviously it's not perfectly linear, but if you take a look at it, I mean, it's pretty obvious that it looks like it's increasing at a decent rate, right? And then drops off. Now it says sketch a trend line that best fits the data. Well, I actually just did that, right? I just drew a line that kind of looks like it fits most of the points, right? So that's what it's saying here. A trend line models the data in a scatter plot by showing the general direction of that data. A trend line fits the data as closely as possible. So I obviously wouldn't draw something like this, right? Because that pink line really doesn't fit a lot of points, only a couple of them. So you want to just try to fit as many points as possible or as close to certain points as possible. All right, there's a big point right here, okay? And that's the fact that when you calculate an equation of a trend line, there are many possible trend lines that would fit the data, right? You might have drawn this a little bit different and picked two different points to work with, which then would change in general, the whole line in general. So you don't have to have the same answer as the person next to you to get the right answer, okay? So keep that in mind as we keep going. Okay. So we want to sketch a trend line that models the data in the scatter plot, and then we're going to write the equation of that trend line. So remember, yours might be different than mine, but it should be somewhat similar. Okay. So first off, I want to draw a trend line. So it kind of looks like it's not coming from 0, 0. It looks like it would come from below it. And it would look something like this. Right? Now, maybe you can think of a different way to go with that, but this is where I'm thinking of starting it, okay? So with that being said, I would pick these 2 points because they are the closest 2 points to that line, right? It actually goes through one of them and it's close to the other one, okay? Could you have picked 2 other points? Absolutely. But I do feel like these 2 represent the line pretty well, right? So let's think about what these 2 points are. The bottom left looks like it's a little more than 2, probably about 2.5, I'd say. And it looks like it's going up 50. The right point looks like it's at about 9. Let me think about that. Yeah, at about 9. Oh, the first one, let's say 3. That's at 3. I was looking at that wrong, right? Because this would be 2. Halfway between would be 3. So that's why this one's at 9, because it's halfway between 8 and 10. Okay, so that's at 9. It's almost at 300. Let's call that 280. Okay. So now we are going to try to put an equation together, right? Think about it. We know what to do when we have 2 points. We're going to find the slope between them first. So change in y over change in x. We're going to do 280 minus 50 over 9 minus 3. So 280 minus 50 gives me 230. And 9 minus 3 is 6. And if I put that as a reduced fraction, I would get 115 over 3. So now that I have my slope, right, now I can put it in point slope. Okay, I'm going to use this first point. So y minus 50 equals 115 over 3 times x minus 3. Now, anytime you write an equation for a line of fit, you want it in slope-intercept form. So we are going to have to solve by distributing in 315 over 3. If we multiply it here, we actually get 115 over 3. So we get 115. And if we take 115, negative 115, and add 50, we end up with negative 65. Which does make sense from my line that I drew. It kind of looks like around 50, negative 50, right? So negative 65 is pretty close to what I drew. Okay. So that would be my equation. If you pick 2 different points, you would come up with a different equation. both being correct. Okay, as long as you're not picking really weird points, right? I obviously can't pick these two because then my line would go this way, which definitely does not fit the data. So just make sure it's 2 points that fit the data pretty closely. All right, so at this point, go ahead and plot these points, okay? Obviously, these are going to be your X's, these are going to be your Y's, so internet speed. And this would be your time to download. So go ahead and plot these, and then I will check back in. All right, so if you graphed this correctly, you'd get something very similar to mine. You might have ended up with a little bit different of a line, but hopefully this was generally what you had, okay? Please be careful when you label things or draw them out. I color-coded these for you to make it simple. So if I were to take 2 points that closely, or that are the closest to what I feel like represent this, would be these two. Okay. Now, maybe you could argue this one as well, but I'm going to take the black and the green. So we're going to focus on this point and this point. Okay. Again, you could have picked 2 different ones. You would just follow the same process. You'd end up just with a slightly different equation, though. Okay, so this does appear to be a negative correlation because it's decreasing. And now we're going to find the equation. So our equation would be 35, 6.65, and 50, 4.65, right? So we're going to go that route. So if we are trying to find the equation, we're going to do change in y over change in x. So this would be 6.65 minus 4.65 over 35 minus 50. First one gives me 2. The bottom one gives me negative 15. So my slope would be 2 over negative 15. From there, I can start writing my equation. I'm going to go ahead and use the first one. So it would be y minus 6.65 equals 2 over negative 15, x minus 35. All right, and then we distribute. So we definitely want to keep our slope as a fraction, but when we take 2 times 35 divided by 15, that does give me 4.6 repeating. And I don't want to keep that as the fraction of 14/3, okay? I'd rather just keep it as a positive 4.6 repeating, okay? Because then I have this decimal over here to add over, and we can add it over and it be a little bit nicer. I am fine with you keeping things as fractions. I just think it gets ugly really quick. Okay, so we have negative 2 over 15x, and then this would be 11.316 repeating. I'm okay if you put 11.3. I mean, this is definitely the most precise answer because it's 3, 1, 6, and then the 6 repeats. All right, so if you did pick other ones, you're going to have a slightly different equation here, but you would have a negative slope and then a positive b. So that's a really crucial part of it. Okay. So we're going to use the equation to answer the question. Well, if we go back up here, our question is, how long would it take to download a 100 megabyte file if the internet speed was 75 kilobytes per second? So this is asking me to plug in 75, right? Because this one automatically is 100 megabytes. So it's asking for me to plug in 75 to x. So if we go down here, we would get y equals negative 2 over 15, and then our new x, which was 75, and then plus 11.316 repeating. Okay, so we have negative 2 times 75 divided by 15. And that ends up giving me a negative 10. And if I add negative 10 to 11.316 repeating, this would give me 1.316 repeating seconds. So it would download in just over 1 second.